Hey, welcome back. Imagine this. The universe is expanding, galaxies are flying apart, and yet some of them still collide. How can this happen? Isn't everything supposed to be moving away from each other? Today, we're going to explore why galaxies collide despite the universe's expansion. Let's dive in. The universe is vast and constantly expanding. Galaxies that were once close to each other are now drifting away due to the expansion of space. But despite this, some galaxies still collide. Sounds contradictory, right? Well, it's not as strange as it seems. To understand why galaxies collide, we need to dive deeper into the forces at work, both on a cosmic and atomic level. We know the universe is expanding. It's been doing so since the Big Bang. The galaxies we see today are moving away from each other, and the farther they are, the faster they seem to be receding. This is a phenomenon we can observe through redshift. The longer the wavelength of light, the further the galaxy. But here's the catch. Despite this expansion, galaxies still collide. So, how do these two ideas fit together? One of the most famous examples is the Milky Way and the Andromeda galaxy. These two galaxies are on a collision course, even though the universe is expanding. How can this be? The answer lies in the nature of gravitational forces and the scale of the universe's expansion. First, let's talk about gravity. On large scales, the expansion of the universe is driven by a mysterious force called dark energy. It's pushing galaxies apart. But on smaller scales, like within galaxy clusters, gravity is much stronger. In fact, gravity can actually overcome the effect of cosmic expansion, causing galaxies that are close enough to collide. Think of it this way. While the universe is expanding, gravity pulls galaxies together in localized areas, like galaxy clusters. Galaxies within these clusters are bound together by gravity, and that keeps them from being pushed apart by the expansion of space. So, even though space itself is stretching, gravity still reigns supreme on smaller scales. But it's not just about galaxies and gravity. Let's zoom in even further, down to the atomic level. On the smallest scales of matter, electromagnetic forces rule. Atoms are held together by the electromagnetic force, and this force governs how particles interact. This brings us to a fascinating concept. Even though the universe is expanding, matter itself is not immune to forces at the atomic level. Photons, tiny packets of light, are constantly colliding with atoms and particles throughout the universe. When photons collide with matter, they transfer energy and momentum, sometimes creating new particles or even triggering nuclear reactions. These photon collisions don't stop because the universe is expanding. In fact, the expansion of space doesn't impact photon interactions on small scales at all. Just like gravity can pull galaxies together, electromagnetic forces keep the atomic world in motion and interacting. Now, let's talk about light itself. Light travels across space, and it can interact with other particles. This is a type of collision that happens constantly throughout the universe. Even though space is expanding, photons don't care about that. They can collide with gas clouds, cosmic dust, and even other photons. Take, for example, the cosmic microwave background, CMB. This ancient light from the Big Bang is scattered all across the universe. It travels through expanding space, but it still interacts with matter, creating subtle changes in temperature and energy. On a larger scale, the light from distant galaxies can interact with nearby cosmic material, influencing star formation and the distribution of galaxies. In essence, while space is expanding, light and matter continue to interact, unaffected by the expansion. Let's bring it all together. The Milky Way and Andromeda galaxy, despite being on a collision course, are still subject to the laws of gravity. Even though the universe is expanding, gravity acts over local scales, overpowering the effect of cosmic expansion. These galaxies are gravitationally bound to one another. The same principle applies to other galaxies and galaxy clusters, where the force of gravity is so strong that it overcomes the universe's expansion, pulling galaxies together instead of pushing them apart. But remember, the universe's expansion doesn't stop at the atomic level either. Atoms, particles, and photons continue to interact, despite the stretching of space. These atomic interactions play a crucial role in the ongoing evolution of galaxies and stars. So, while the universe itself is expanding, Local gravitational forces and electromagnetic interactions ensure that galaxies can still collide and light can still interact across vast distances. So we've learned that even though the universe is expanding and galaxies are moving farther apart, gravity and electromagnetic forces are still strong enough to pull galaxies together in certain regions. This is why galaxies within clusters collide, like the upcoming merger between the Milky Way and Andromeda. On a smaller scale, photons and atomic interactions continue to happen without interference from cosmic expansion, further proving that even in an expanding universe, forces like gravity and electromagnetism still rule the cosmic dance. In the end, it's the balance between these forces, gravity, electromagnetism, and the expansion of space, that shapes the universe we observe. Thanks for joining me on this cosmic journey. If you enjoyed this exploration of how galaxies collide despite the universe's expansion, don't forget to like, comment, and subscribe. Got any questions or thoughts on how gravity and light interact in space? Drop them in the comments below. I'd love to hear your ideas. And stay tuned for more deep dives into the mysteries of the universe.